Good day everyone, this is Sai Anirudh Kare from Software Engineering Research Center, IIIT Hyderabad. Today I'm here at 14th Innovations in Software Engineering Conference to share our experience report on using project-based approach to teach design patterns. The course is designed for baccalaureate third, fourth and post-baccalaureate students with a special focus on design topics in software engineering. As these students do not have exposure to large-scale project setup, our focus on architectural design is limited. Majority of the focus is on subsystem design and code smell. Based on our study, we believe that these three following aspects play a key role in conducting project-based learning for teaching design patterns. The first one is the choice of the project. The project should span for a minimum time of about 4 to 6 weeks in a given semester, neither too large nor too small, with fixed deliverables. Instructor should have competency with tools, techniques being used as part of the project and should have contacts with practitioners and industry experts so that they can share feedback with the students while they develop the project. Third aspect is the students. They should have a beginner level programming and should have interest and commitment to address defined tasks and understand the results of the project. We created teams as part of this activity with mixed demography. As part of our course, we have third, fourth, and few of the postgrad students. We combined them and ensured that we had a team size of 3 or 4 with a mixture demography. We defined clear deliverables. We captured progress over a fixed interval by assigning respective mentors to each team so that they provide instant feedback and help them plan and ensure that they deliver on fixed deliverable deadlines. As part of our design pattern project, we provided students with desktop simulation of bowling alley game built by inexperienced undergraduate students of Rochester Institute of Technology. Relevant concepts of design patterns were taught in a classroom setup while we let the students undergo this project. The project is divided into two stages. In the first part of the project, students are expected to run this code, the existing source code, against their desired metric tool, and they're supposed to capture metric data on code smells. They eventually have to refactor the code and improve the metric data to show that the refactored code is better compared to the existing source code. There are designated mentors who are teaching assistants to this course, guide these teams on choosing a right metric tool and letting them undergo the process of refactoring and capturing the improved metrics. The step 1 will be evaluated as part of the project presentations, and all the teams get to know the tools, the metrics, and the way the refactoring was done among each other. As part of stage 2, we ask students to implement design patterns and think about new features so that they can implement them on top of this newly refactored code. These tasks are executed as a team. All the team members follow submission instructions and they conduct a peer evaluation among the teammates. All the submissions are made on Git. There are individual contributions recorded. When it comes to evaluation, we grade the stage 1 and stage 2 of the project with a predefined rubric. The mentors who are part of the respective teams who guide these teams, they join the stand-up calls of the respective teams and share constant feedback. We found that the students have captured metrics from variety of tools like Metrics 1.3.6, J Deodorant, Infusion iPlasma, and eventually have refactored the code and gathered very valuable code metrics. They're also able to identify bunch of code smells and anti-patterns in the existing bowling alley source code. Also, as part of stage 2, they have implemented variety of design patterns like proxy controller data access. And we also found that adopter and trigger pattern were least commonly used as part of their code submission. As part of this exercise, we found that grouping students who had not worked together had encouraged them to put on additional effort on understanding each other's and their coding style. It also became a space for these teams to work at the competitive spirit and exhibit their skill set on implementing refactoring, or it can be implementing design pattern, so that they become relevant when they share this information with rest of the teams for feedback. The critical reviews as part of this process by mentors, the instructors, and the other peer evaluators or the other team members has really helped respective teams to produce very good design and also effective way of implementing design patterns. And some of the teams have actually come up with genuine new features which are very interesting for when compared with the existing bowling alley game. Documenting the changes and presenting the changes or the implementation with the other team on a same project really helped all other teams to understand their designs in a better way. And the confidence of this exercise among students, we conducted a student confidence survey using the existing confidence survey in the literature. We asked the students about their levels of confidence on implementing the design factors and design patterns and refactoring. And we found that 58% of the students have said that they have complete confidence now on implementing design patterns in their future product development. 34% of the students found that handling refactoring was effective, and they were confident in using the tools on any source code. 7% of students were neutral about the project, and they said that they have uh, less impact on understanding the design pattern concepts. We would like to conclude that as part of our experience study, we shared our observations on implementing a project-based approach on teaching design pattern to grad students. The students who participated in this project-based learning were able to refactor and implement design patterns on existing defective source code. We conducted student confidence survey, which has provided positive results. And we encourage instructors to set up a similar project-based approach with in a duration of a typical semester of 4 months. They may adopt our approach or suitable variant of it, so that they can teach design patterns effectively and end up generating productive software developers. The source code for Bowling Alley Defective Project, the resources for all the code submissions, their metric data are made available as part of the resources in the paper. Thank you for your time. For questions, you may mail us at the following email ID: